What's good, space weather enthusiasts? Perhaps we'll get some Earth weather enthusiasts in the video tonight as well. Welcome to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Bash. These are 24-hour SDO videos featuring two different species of ionized iron and their extreme ultraviolet emissions in the solar corona. You've got the raw 171 angstroms imagery as well as the interlaced 211 angstroms 60-minute running difference imagery. And I saw there was a cool prominence down there in the southeast, so I figured I would start out tonight's video with that. There's the equatorial zoom. It looks like there are some issues there with some of the difference imagery, causing that odd little blurring type effect there at the beginning. And there's the full disk. Or maybe the SDO got hit by gamma rays. I don't know. Could be. Anyway, let's take a brief look at sunspots here. And we have another uptick in sunspots since yesterday. So it looked like they were actually degrading to me. If I would have had to have guessed, I would have said sunspot number would have gone down today. It indeed went up. There's the colorized magnetogram as well for today, January 6th. Very nice, very nice. Additional sunspots. Who ordered them? That was the title of yesterday's video. And by the way, like I said, we may get some regular weather nerds showing up on the video tonight. So there's what's going on in Allentown, Pennsylvania. And you may be wondering where the muggings are most likely to happen. Allow me to get off the screen so you can see the police down here. So we've got the police right here. So there's the police. Muggings. So this is here's a spot. You could have some muggings there. Some muggings over here. Those are out of the line of sight of the police. Down the block here. Those areas will be the prime spots for muggings. So if you want to watch that webcam yourself, it's the Fox 29 Weather Authority. And let's talk volcanoes. Hopefully no muggings erupting in Allentown. And there are the volcanoes that are erupting around the world. Here's a brief look at the list. The Reykjanes Peninsula has been downgraded from considerable at orange to moderate at yellow. Among the other honorable mentions are, well, maybe I'll mention some here. Luatobe doing a 10,000 foot ash plume. Dense gray brown to brown ash plumes. Sounds tasty. Popocatépetl, 18,000 foot ash plume. Nevado de Ruiz is today's volcanic winner. 23,000 foot plume of volcanic ash, flight level 230. There's a volcanic map for you. And next, earthquakes. Earthquakes. Do we think they're caused by the sun? Is that why we put them in the videos? Well, no, I don't think they're caused by the sun. But anyway, there are the past 90 days. Here's what's been shaken for the past 24 hours. Carlsberg Ridge had a 5.6. Not to be confused with Carlsberg beer. That located in the Indian Ocean. Not the beer, the ridge. That was at 11:46. Also, Southeast Pacific Rise. Out in the middle of no man's land there. West of the Galapagos, there was a 5.1. Kermadec Islands had a 5.1. North of Japan. That one is the one I meant, not Texas. And that's it. Pretty calm as far as earthquakes for the past 24. And let's get back to some space facts. Actually, let's take a look at some more solar imagery first. Well, those are facts. That's a whole series of data. The classic 171 angstroms wavelength. And before we talk about stuff like coronal holes, let's talk about stats. The radial flux now up to 153, I think it is 153 for the 10.7, otherwise known as the F107. There it is in a one-year chart. The black line is the radial flux. Red line is the sunspot number, which is coming up to about 150, by the way. We'll get to it. NOAA not forecasting any geomagnetic storms or geomagnetic unrest. So it's quite calm, and it's going to stay calm in space weather. Actually, radial flux up to 159. There you go. 159 is the new radial flux. And let's take a look at Earth's magnetic moment from space. Space, a frontier. These are the voyages of Earth. That's what a proton has to experience. That is the minefield that a proton experiences as it tries to make its way through the solar system, Earth's magnetosphere. It's about 12 Earth diameters in size. And it looks like we just had a little increase in the solar wind. Here's Earth's magnetic moment from the ground. We'll get to the solar wind here in a moment. That happened while we were doing show prep. What is it? What's going on? Is a CME happening? Well, we'll get to it. And right there at the end, a little uptick there, some kind of a perturbation happening in the solar wind undoubtedly. Most likely, at least. But it is geomagnetically calm at the moment. KP 0.67 having been in a KP 0.33 for an extended period there. KP 0.67, very geomagnetically calm. And here's the solar wind. It's slow and diffuse. Less than 2 protons per cubic centimeter as measured by the ACE. And only 335 kilometers per second. Slow and diffuse is that solar wind. Discover detecting a much denser solar wind. Between 4 and 6 protons per cubic centimeter. And also much faster at the Discover. So another interesting dissimilarity there in the ACE versus the Discover as they orbit the same point, Lagrangian point 1. So 474 kilometers a second, much faster speeds there at the Discover than at the ACE. GOES magnetometers are smooth, getting the highest reading in a while there by the GOES 18, the blue line, reading up to 106 nanotesla. There's a 7-day graph to better contextualize that, in case it's Greek to you. And here's our top view ecliptic plane field plot. And it looks like Earth remains in a North Pole sector. By tomorrow, a South Pole sector looks like it's likely to be here. It's the magnetism of the heliosphere. North Pole sector about to end as a sector boundary crossing comes, shown there in red, to the South Pole magnetism. So that's a thing. Sector boundary crossing coming in the next 24. There is our line of sight field plot. A lot of different important features there. If anybody would like to describe it in the comments, please do. The line of sight field plot, it shows you many things for the past 4 days. Next, our line of sight coronal hole field plot. And yeah, like I said, South Pole sector coming. The magnetic tug of war that was happening in the northeast has ended, and the South Pole magnetism has won, as you can see right there, up there in the northeastern hemisphere. South Pole magnetism. So there are coronal holes from SDO. And basically what we're looking at here is these are south and these are north. Which brings us to sunspots. Sup with sunspots. You may be wondering, well, we've had a large increase in sunspots since yesterday. Sunspot number now about 146 as we approach the 150 mark. So let us know in the comments if you think sunspot number will rise or fall by tomorrow's daily space weather video. We want to know what you think, so leave a comment and tell us, will sunspot number rise or fall by tomorrow's daily space weather? Take a guess. Take an educated guess. Take an uneducated guess. Flip a coin. Consult tarot cards. Roll dice. Consult a punch board. Flip a manhole cover. Wait, don't flip a manhole cover. Flip something. Allow Zeus to decide. Perhaps consult the Oracle of Apollo. So here's the situation, and it looks like sunspot number is going to be going up tomorrow, unless some rapidly degrade, because I can see right here that several are not named yet. So they may already be counted, but it looks like sunspot number will increase, because the loss of 3534 is not going to cancel out all of these new groups in the northeast, and in the southeast also, perhaps. Anyway, let's take a look at sunspots here from SDO. There's SDO Continuum from today, and let's see. I think we'll have 2 to 4 new named groups by tomorrow. So it looks like sunspot number is going to continue to rise. We do have some growth of this group up here. This group also has grown quite a bit since yesterday. Most of the rest looking pretty stable. Continuing right along, the proton event is still subsiding here very slowly. Like I said, when it happened, these things can last several days, and well, there you go. It's lasting several days. The South Polar Radio blackout has turned into a South Polar Radio brownout, and that brownout will be subsiding as well. North Polar Radio blackouts are pretty much completely gone now. South Pole ones are almost gone. Keep in mind, it is summertime down there. As far as flaring, no major flares, but the background X-ray flux has come up to C1 and a quarter. It's a C1 and a quarter background flux, folks. And let's take a look at sunspots up close, because we've got some splentacular imagery for you here from the SDO HMI instrument. There's a great view of those new spots in the southeast, and indeed there is one to the, there's actually at least 1 or maybe 2 new named groups that we'll have up here. So yeah, we're going to have 3 or 4 new named sunspot groups by tomorrow, folks. Sunspot number continuing to rise, it certainly looks like to me. So here are the magnetic fields of those quite strong looking groups. Not all that much volatility there, so they are fairly stable looking sunspots. These sunspots are a little bit less stable looking. The one just to the left of the Earth scale there has been growing rapidly, but its magnetic fields aren't super extraordinary. That's a lot of sunspots in one shot, though. Here are the magnetic fields in that area, a little bit more sparsely distributed, but a little bit more chaotic. So, for example, here's a great example of some magnetic shear, which has actually degraded right down here. You see how there's like this dark plus this light and this nice demarcation line right there. That is magnetic shear happening. So those are the areas where we expect to see solar flares happen. This area right here, wherever you see very strong lines that are in proximity to each other. It looks like this one's getting volatile up here also. So if you spend a little time looking at this and understanding that you can forecast solar flares, you'll find that you are able to do so by looking at the magnetogram. This is not revolutionary stuff. It's been known about since the early 2000s. Anyway, let's get to flares, since we talked about flares last. There's 94 angstroms plus 131 angstroms, 60-minute running difference. And indeed, you can see that the most active sunspots are the ones that have that magnetic shear associated with them. So here's 3536, which has been, well, the largest flare-producing sunspot in the cycle, at least in terms of producing the largest flare. And here are those sweet-looking groups rising over the southeast. fine example of how larger sunspots don't necessarily equate to larger solar flares. And before we get to CMEs, let's take a moment to see what's going on overhead. So this is what's happening over Lehigh Valley. Jupiter and Saturn are up there, and you can't see them because it is snowing in a champion fashion. So I'm always very excited about that. Huge fan of the snow. Anyway, here's our solar system forecast. We'll get to meteorology here momentarily. That's where things will be in a week. There's your 1 week's forecast for the solar system. And check it out. Here's some snow falling, and this is cometary snow on Comet Churyumov. Yeah, I'm not going to say it. I'm over it. So yeah, there's a lot of things going on in this. It's really awesome because it's got. So first of all, you've got dust and ice particles that are actually coming down. You've got background stars that are streaming past, which is Canis Major. And then you've got some other streaks on there, which are likely energetic particles like solar protons or cosmic ray particles striking the camera as well. So lots of stuff going on there. You can see the background star streaming past. You can see these particles falling. That is just insanely sweet imagery there. From about 13 kilometers away, I think it is. Yeah. It cruised some 13 kilometers from the comet's nucleus. And yeah, that's the astronomy photo of the day. Just freaking awesome. A blizzard occurring on a comet. And let's get to CMEs. CMEs. These are the Smash News Networks, the least busted name in news. Here are CMEs from today. Do we have some earthly directed ejecta? We might. Fingers crossed. If you're spooked of CMEs, please get into your bunker. Get into your bunkers, folks. All right, here we've got the C2 and C3. If those are earthly directed CMEs, they're pretty diffuse ones. Sorry, they won't be ending civilization, folks. Terribly, terribly sorry for all of our viewers who wish civilization would end. Terribly sorry, folks. We're unable to forecast doomsday once again today. With great regret, we're not forecasting doomsday. Terribly sorry. And, oh, before we get to filaments, here come our custom coronagraphs. So sadly, there's a bunch of missing data there, so it's not really synced up right at about 1300 or something, or 1600 today. Now, wait. At about 1400 Universal Time today, the C2 and C3 stopped sending data, or HelioViewer stopped obtaining data, or something. So, yeah, there could be some minor CMEs on the way. They would want to arrive sometime around, like, late in the day on the 9th. That's my best guess. You can only sync so much data, but it looks like there was definitely some ejecta coming out of this area here. And so, yeah, I suspect there is a CME about to strike on the 9th. Possibly as early as early day on the 9th. It looked like it was pretty high speed there, so could even be late day on the 8th. So probably early on the 9th, though, would be my best guess. There you go. The SDO 304 angstroms, 60-minute running difference, plus 193 angstroms by itself. That CME came from this area right in here, and there it goes. Flapping its way there out of the solar corona. Looking quite interesting there. Maybe that was a relativistic particle strike associated with the release of that plasma filament. Maybe that's what caused the issues with their running difference imagery. Not so sure that it isn't. It does suspiciously happen right at the exact time that filament release occurred. So that can be a thing. Did we have a spike in the proton flux at that time? When did it happen? At about 6 o'clock this morning, I think. Yeah, it looks like about 6 o'clock this morning. Was there a spike in the proton flux? I wonder. And the answer is not really. Not really. So anyway, that's a 24-hour video, a great view of that releasing filament. And let's take a look at filaments, since it's that time anyway. It's filament time. Wow, I've got a lot of tabs open yet. I got to blast through these tabs, folks. It's time to kick it up a notch. So there are plasma filaments, and there are lots of them, including the prominence that we started out the video with, right down there in the southeastern limb. Ta-da! That's what's going on. There's the colorized view from Cerro Tololo, Chile. And somebody wants to name these, but they haven't, over on Twitter. Follow the hashtag NameThatFilament over on Twitter. Follow the hashtag NameThatFilament to name filaments after your friends, your foes, or even yourself. Here's the past couple of hours. And is that getting unstable? Oh my God, is it going to end civilization? Well, definitely not. Anyway, it's time for bonus features, so let's do it. Satellite charging hazards. We ain't got none. It's smooth sailing for satellites. There you go. Surface charging and internal charging hazards showing green for things like the GOES 16 and GOES 18. Electron flux here, there you go, normal operating range. There's the 1-year graph. It's actually kind of on the low side, but not particularly low. We should be seeing an uptick in this. However, there has been a lack of space weather. There's the forecast and almost flat levels here forecasted by NOAA, so tend to agree. Here is the ionosphere map is coming next. It's this portion at about 300 kilometers of altitude. So that is the layer known as the F layer. And the way the electron flux is measured is using radiography from way above that. So the GOES 16 and GOES 18 are at like 23,000 miles of altitude. This layer of the ionosphere is about 300 kilometers of altitude. Here's the anomalygram for that same period of time, the past 24 hours. And things are looking quite normally. Wake me up before we show you the total ionosphere forecast. Wake me up before we go. 'Cause this, viewers, is the wham. It's the wham, folks. The whole atmosphere model. There you go. Total electron content as well as maximum usable radio frequency. We'll close out space weather once that plays through with the latest solar intensitygram continuum and magnetogram. There you go. That's what's going on. Again, multiple new sunspot groups. There's one. Okay, that one's no longer a sunspot. So there's one and there's two. And I think that one might not have a name yet either. So anyway, that is what is happening. And it's time to get to meteorology. Let's do it. There is the pressure map for planet Earth. The world's lowest pressure is still out near Alaska, it looks like. Yes, indeed. That low continues. Look at that. Look at the size of that thing. Dag, it's like a hurricane. 950 hectopascals. Dude. That is a serious low. Bruh. It's a serious low, bruh. Bruh. Do not bro me. All right. So, anyway. These are the surface winds of the east. These are your jet streams. Jet streams of the central world. There you go. As we connect your space weather to your Earth weather, there are the surface winds of the central world. Heavy winds in the Mediterranean. Yeah, it's stormy seas in the East Mediterranean. There is the Western worlds surface wind scenario, and there is the jet stream scenario. Here is clouds and fog over the west. And let's take a look at this system that everybody's talking about and everybody's getting inundated by. Finally, some measurable snowfall. Exciting stuff. It's not going to be that extreme, and it's going to be followed by rain events, although the temperature will not rise up very high. So many places will see all that snow gone, and Philly is already only getting rain. So we'll get to it. There is our snow depth map for the moment. Dag. Lots of the country currently with the white stuff. The visible satellite's going to be pretty bright in the coming days. Anyway, here's our weather.gov map. Weather.gov, there are your weather warnings, and here come some forecasts, starting with the GFS 72-hour pressure and precipitation forecast. So high pressure is going to build over the Mississippi Valley, and then it's going to blast that weather off real quick. It's going to go flying. And there is our accumulated positive snow depth change in inches. An additional event coming through. But for Lehigh Valley, it will only be rain for the second portion. So there's the total accumulated precipitation in inches. And heavy rains there coming to Mississippi and Alabama. Dag, that's going to cause some flooding, folks. Mississippi, Alabama, Georgia, parts of North Carolina getting 4 inches of rain. Major rain event there. So here's part of what's going on. I'm showing you the result first and the how last. So this is how it happens. Pressure gradients, folks. Pressure gradients. So here's the high pressure that builds in the Mississippi Valley, and it's going to push all that stuff out. And guess what? Another low is going to follow it. So that's going to bring more precipitation in the next couple of days to the eastern portion of the country. Here's our temperature forecast. These are all the same model, the GFS 72-hour model. And you can see in Pennsylvania, for example, temperatures are only going to get to about 35 degrees over the next few days. However, the second event will be just rain. It must be a daytime event. So there is the jet stream, which is really the culprit. And you can see once again this kink in the jet stream, pushing some cold air through and so forth. Anyway, there it is, 72-hour jet stream forecast, 250 millibar winds. The real culprit, forcing your weather from west to east. It's not HARP, since that's not weather modification. It's not contrails. It's not chemtrails. It's not cloud seeding. It's nothing like that. It's the jet stream. Cheers. Anyway, here is our, this time we decided to bring up the long wave dirty radiation map. Yeah, the dirty long wave radiation map, to show a very detailed view of the water signals there in the atmosphere. So there's where the moisture is. And man, oh man, that certainly does look dirty. Let me switch that to the clean. All right, so I brought up the long wave radiation map, a different one here. This is the 11.2 micrometers, nanometers, micrometers. And yeah, it doesn't look any better, so let's move on to lightning. And there's not a lot of lightning, so who cares? Let's look at a Philadelphia webcam, because I wanted to show you what's going on in Philly. And it is just rainy in Philly, folks. No kind of snow in the city of brotherly love. So there's Philly for you. And here's Bethlehem, Pennsylvania, though, where it is a winter wonderland. So here you're looking across the New Street Bridge, also known as the Fahey Bridge. And you're looking north there from the south side, Bethlehem. The Lehigh River is right here, right underneath this bridge. And then this is historic Bethlehem right over here, where the old historic Bethlehem, where you have a Moravian gift shop where you can go buy Moravian stars, and the library and all that stuff. Historic Bethlehem, Pennsylvania. You're looking toward it here from the south side. And I think we've also got, that is a Lehigh University cam. Let's take a look at another one here. Here's another really awesome one, the Clayton campus of Lehigh University. There are some really old school buildings getting some awesome renovations there. Lehigh Valley snow. And by the way, press the like button if you enjoy the content. Tell your friends and foes about us. We remain surprised that you've found the channel, especially in light of the past few years. Cheers for the past few years. Thanks to each of our viewers for not being dead. Don't forget to count your blessings and press the like button. Yeah. It's only the world's most comprehensive daily space weather content and most detailed solar imagery you'll find anywhere. No big deal. And yes, our shorts are quite popular indeed. Anyway, we'll close things out with U.S. Doppler radar, clouds and fog, and the water vapor. So here's a prime example of the water vapor map showing you what's going on. Guess what's going to happen? You're going to have a massive pressure gradient with high pressure forming back here, but we'll get to it. So there is the nor'easter, and the heaviest precipitation is yet to show up here. It's just about here. By the way, we're located somewhere around this area here in Lehigh Valley, Pennsylvania. Some of the world's finest bicycling roads and communities. Anyway, there is the full 50 state view as this low is hanging out in the Bering Sea. We're showing the lower 48 to close this mother out. So there is the clouds and fog as more Pacific moisture makes its way into Southern California. Look at the moisture. Blow. Moisture just blasting through there, folks. Yowzers. And so, like I said, here's this high pressure. You can see this dry mass of air here creating quite an impulse to move that moisture out. Like I said yesterday, the dry mass of air pushes the moist air around. Here's your recap. Ground-based Doppler radar systems. This is why it's often windy after a snowstorm. Windy, clear, and blustery, because the high pressure moves the moisture out. There is the clouds and fog view, 3.9 micrometer infrared radiation, and there is the water vapor map showing the dry air, the moist air, and everything in between. Anyway, see you next time at the Daily Space Weather Show. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. Headed back to the bunker. And in the meantime, may that solar wind be at your back. I'm going back to the bunker again. All that awesome tomato soup I'll be dipping my grilled cheese in. Ha ha.